This is Linux in Laws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. Welcome to Linux In-Laws, Season 2, Episode 20. Martin, how are things tonight?
Yeah, all good, all good. How about yourself?
Can't complain. Normally we talk now about the weather or the state of
Upcoming
the British...
election,
upcoming elections and the state of the union, I'm almost going to say, in Britain, but given the fact that Britain is not a union any longer, never mind united, but that's beside the point. We might as well digress into tonight's topic directly. And without further adu, I would like to introduce Bill Mulligan. But before I disclose too much, Bill, why don't you introduce yourself?
Sure. I'm Bill Mulligan. I currently work as a community pollinator at Isovalent, which is now a part of Cisco. I'm a maintainer of the Cilium open source project, and I also work a lot in the upstream eBPF community. And I'm super excited that you're having me here. Perfect.
With that said, I think all is explained enough, and we would like to thank you for listening to Linux In-Laws. No jokes aside. For those two people in the audience, Bill, who do not know what Isovalent, what eBPF, and never mind what Cilium is, why don't you give us the 6,000-foot overview?
Sure. So I'll start with eBPF. So eBPF is a Linux kernel technology. And the really high-level kind of analogy that people like to use is eBPF is to Linux kernel what JavaScript was to the browser. So it essentially allows you to make things programmable. So before you had kind of static web pages, and then JavaScript allowed you to have interactivity in your websites. eBPF is kind of doing that for the Linux kernel now. So it's allowing you to rather have like multi-year innovation and development cycles. You can add eBPF programs into the kernel and change the functionality in a safe and performant way. And so eBPF is kind of like the background technology behind Cilium and also Isovalent. So Cilium is a cloud-native networking, observability, and security tool. It originally began as a way to connect containers in Kubernetes, but kind of since that humble beginnings, it's expanded into a lot of different areas, from networking from layer 2 to layer 7, doing a lot of observability, especially network observability, and also providing security to the networks and really the Linux kernel as a whole now too. And then on top of that, Isovalent is the company that founded Cilium, and also the co-creator of eBPF also works at Isovalent, and we're focused on helping enterprises adopt eBPF as an underlying technology and Cilium and other Cilium projects in the Cilium family, and be successful at enterprise scale.
Okay, great introduction. So we haven't actually discussed what the abbreviation stands for, but that is kind of irrelevant right now. The sort of the story around eBPF is that it's mainly based on networking. Can you kind of dive into that a bit more and how it fits into the kernel?
Yeah, sure. So the way that eBPF began, it actually has its roots in the networking technology, the Berkeley Packet Filter, so BPF. And what Berkeley Packet Filter allowed you to do is it allowed you to filter different type of packets inside the Linux kernel. But really what it was is kind of like a little VM running inside the kernel, allowing you to run specialized programs. And so about probably like 10 years ago, a little bit more than that, because eBPF is now 10 years old. Some developers were looking for a way to add new functionality in the Linux kernel. And so they saw BPF as a way to do that, allowing you to run specialized programs within this kind of secured context of the Linux kernel. And so they started to work with the upstream community to add additional support into the original BPF. And so that's where we kind of came to the acronym eBPF, which originally stood for Extended Berkeley Packet Filter. But now that kind of like the use cases of eBPF have expanded so far beyond just kind of like networking, the acronym doesn't really make sense anymore. So we kind of call it a pseudo acronym now, where it just stands for kind of the technology as a whole. So eBPF is a standalone term now. And it's basically, I think what it's trying to capture is that it allows you to add programmability and flexibility into the Linux kernel. And yes, it originally began in networking, but as you can see with Cilium, it expanded to things like observability and security. Other people are using it for things like tracing and continuous profiling. Linus Torvalds finally said that he's, actually just this week, said that he's going to allow writing CPU schedulers in eBPF. And I think kind of like the quote that I really love that was in one of the articles I read about this is, you know, the eBPF juggernaut has really overcome all the objections that have been placed in its way. And so I think that's the exciting thing about eBPF right now is it's allowing us to rewrite so many parts of Linux kernel, you know, kind of this 30-year-old technology and bring innovation back into it. And so I think that's kind of like the exciting thing about the technology right now is it allows us to kind of, it enables us to rewrite anything. And now the question is, what should we rewrite first? And so yes, it began in networking, but now it's expanded to so many other use cases too.
Yeah, I mean that begs two questions, right? If you look at it from a high level and rewriting kernels, then first question is why not make some? If you want to change the Linux kernel, why not do some commits to that, right? Or make some pull requests on that. And the second question is how do you make sure that what is the kind of the runtime environment for these extended modules, right? And how do you maintain let's say the stability of the Linux kernel by introducing a third-party piece of module that runs inside the kernel or in a virtual machine?
I'm almost tempted to say, how do you squeeze in security into the whole thing if you allow
that too,
user programs in inverted commas to enter the kernel? So lots of questions.
Yeah. I'm happy to answer all the questions. That's what I'm here for. So which one do you want me to start with?
Next week's lotto numbers would be fine. No, I'm joking. No, I think we should probably start by explaining how to extend the kernel and what the main differences are between modules, which you can also use to extend the kernel with eBPF in general. But maybe also now's the time to chat 2 sentences on the history of the Berkeley Packet Filter.
Sure. Yeah. So I can talk a little bit about the difference between like a kernel module and the way that eBPF works. So a kernel module, right, is something that you kind of load into the Linux kernel to extend the functionality of it. But, you know, the Linux kernel is a really kind of like critical part of your system, right? If you crash, hang, or otherwise harm Linux kernel, you can take down your whole system. And I think really one of the key focuses of eBPF was the safety of the Linux kernel, because it is so critical to everything else that we're doing. And so eBPF kind of ensures this safety in a couple different ways that like traditional Linux kernel modules don't. So the first one is eBPF has a verifier. And so what this verifier essentially does is it checks all the programs that they're not going to harm, halt, stop, or otherwise, you know, kind of interfere with the Linux kernel in a bad way. And so, like, originally it was like things like limiting the instruction set size, not doing unbounded loops, making sure it wasn't calling memory out of bounds, things like that. And kind of as eBPF has kind of progressed in the last 10 years, the verifier has kind of been expanded in what it's able to cover. And so it's like the instruction set limit is up to, I think, over 1 million instructions now too. But kind of like what the eBPF verifier is meant to do is ensure the safety of the Linux kernel. As you're loading programs into it, that those programs won't harm the system. And then kind of like the other part I know, like on the security side, is that eBPF is kind of disabled by default. So if you're just like an average user, you can't just load any arbitrary eBPF program into the Linux kernel. Like obviously you wouldn't want that. Loading eBPF programs is only allowed by privileged users. And so if somebody is already an admin on your system, you probably have other problems besides worrying about like which eBPF programs they're going to try to load into your system. So, right, that's a little bit on the security side. And then also on top of that, so once the eBPF program is verified, it's going to be loaded into the Linux kernel, and then it's going to be JIT compiled into like the machine-specific instruction set. And that allows you to essentially run eBPF programs as fast as natively compiled Linux kernel code. So you get a lot of safety and performance benefits that you don't get from traditional Linux kernel modules.
So eBPF does include a just-in-time compiler. Is that what I'm hearing?
Yeah. That's
wow.
Correct.
And given the fact that if you allow so many instructions and never mind the complexity of the code, sorry, just wondering, what do you normally use as a programming language if you want to program such an eBPF module?
Yeah, most people use C, but obviously because it's a bunch of Linux kernel developers, or C++. There are libraries for other languages too. So I know there's one for Go, one for Rust. I think there's one for Python, and now there's actually even one for Java too. So you can write your eBPF programs in Java.
And they all get verified and then translated into this bytecode, which is eventually transformed into machine language.
Yeah, exactly.
Wow, Python, Rust, Martin, there you go. You can max yourself out even with Golang.
Yeah.
Do you have some examples of types of modules people write with? Well, I'll call them modules, but if there's a better word for them. What would you call an eBPF application?
So the way that we think about it is an eBPF program, because what you're doing is you're essentially running a specific program on a hook in the kernel. So it's really event-driven programming. So like open this file, read this thing, create this socket, like all of those are specific hooks. So it can be something like a syscall or a kprobe or a uprobe. So it's like specific points in the kernel that's what eBPF programs are triggered off of. And so I would say your essentially the eBPF program is running to do one specific thing. And now, like, this is a little bit more, like you can tail eBPF programs off of one another. So you can like chain multiple eBPF programs together. So it doesn't all have to be off of something specific in the Linux kernel, but it can be like the first program runs and the second program runs and so forth. And the other thing that you can do is you can also, there's these things called eBPF maps. And what that allows you to do is essentially like share memory between the kernel space and the user space, right? So if you're trying to like capture different data in the kernel, and then you can parse some of that data, and then you want to export the rest of it to user space for further or more complex processing, you can do that too, right? So you're capturing the data in kernel space. You might be processing a bit of that and then exporting it to user space to do whatever you want to do with it too.
That sounds like an ideal tool, for example, for tracing functionality.
Yeah, exactly. And that was one of the kind of like use cases that Brendan Gregg originally popularized at Netflix, looking at essentially system performance and, doing tracing and like flame graphs with eBPF.
Interesting. So that opens up the kernel in a very guarded fashion, unlike kernel modules, because if you load a kernel module into the kernel, it's pretty much allowed to do whatever it wants.
Yeah, exactly. So it's allowing you to extend and modify the functionality of the Linux kernel, but in a safe and performant manner.
Can you shed a bit of light on I mean, you work for an organization, right? And clearly they have a a benefit or an interest in eBPF. How did that came about to turn that into let's say, a commercial organization that's recently been acquired?
Yeah. So, there's actually, if you want the real backstory on this, I would really recommend the eBPF documentary.
Okay.
So just go to ebpfdocumentary.com and you can find it.
Links, of course, in the show notes.
Yeah, and it's kind of like a Netflix-style documentary diving into the history. I mean, like you see the movie poster and it looks like an Avengers movie poster with kind of like all the bosses and everybody looking like a superhero. And it's really, really well done, but it actually dives into kind of like the history of how it came about. And there's like a couple different threads that kind of went through there, but I'll just like focus on the isovalent one. Mm-hmm. So at the time, one of the founders of isovalent, Thomas Graf, and Daniel Borkman, who is the co-founder of eBPF, were working together at Red Hat and doing a lot of stuff around SDN and Open vSwitch. And they kind of saw the problems of like trying to get things upstreamed in the kernel. And they also saw kind of like the next generation of technology was coming. We're kind of going from this world of VMs towards containers and like cloud native, and things are going to be moving a lot faster. And so kind of at the intersection of this, they saw we need to make the Linux kernel more programmable to keep up with the demands of what's going to be coming for technology. And that's when, at the same time, there was someone called, there was Alexei, who was actually working at a startup called PlumGrid. And he was also kind of like running into the same challenges as them. And he worked together with Daniel to kind of get the first iteration of eBPF into the Linux kernel. And then once they did that, it was kind of like this big moment where essentially Thomas says this in the documentary. It's like, we can rewrite everything. What should we rewrite first? And since they kind of had their background in networking, that's where they decided to start with. And that was kind of like the birth and the origin of the Cilium project, was using eBPF to redo networking for the cloud native and the container world. And so what originally began as like a flat layer 3 network for connecting containers, eventually spanned into multiple different projects that Isovalent has today. But kind of the origin story was they saw the potential of eBPF to transform how we're doing a lot of technology. And the project that they started with was Cilium for networking. And then now that kind of scope has expanded into multiple different things, with like Hubble for observability and Tetragon for security. But it originally began with kind of like this networking story.
Now that we've probably managed to put half of the non-technical audience to sleep, maybe we should change tack a little bit with regards to, you just touched upon Cilium, which I think is a cloud computing foundation native project, or at least Linux foundation native project by the looks of it. Given the recent rage and recent, of course, meaning for the last 10, 15 years about container computing, maybe you can put, or you can add a little bit of context why Cilium is exactly addressing, and if possible in a kind of non-technical way, because not each and every of our listeners is actually technical. Why is Cilium so important, especially in a container or /VM context, as a networking core foundation technology for other people's computers, also known as clouds?
Yeah, so Cilium, I guess, first of all, so it's a graduated project in the Cloud Native Computing Foundation, which is kind of like their highest level status, which means it's like widely adopted across the industry, and it's become the standard, we call it CNI, Container Networking Interface, for all the major cloud providers and thousands of companies across almost every single industry now. For kind of like taking it back a step, so when we're looking at the kind of the transition from the VM world to kind of the container and the cloud native world, I think like the biggest transition is kind of like the speed and the dynamicism of like how fast things are changing, right? So you could have long living VMs, but all of a sudden you come into this world where there's a lot more containers, and there's a lot more speed with which they're created and destroyed too, right? And so if you talk to any kind of like traditional like sysadmin, they probably like name some of their servers and they can tell you like the most important IPs in their data center, right? And that kind of like whole model of how you think about things, being able to memorize things or be able to keep track of all of them on a spreadsheet just completely goes away in the cloud native world because things are moving so much faster. The IP that you memorize isn't going to be relevant 5 minutes from now. So you really need to rethink how you're doing a lot of these different things. And so what Cilium fundamentally kind of does is rethinks a lot of these things for the cloud native world. And I think like the biggest example I can give is kind of like the transition from IPs to identities. If you've ever like been in the DevOps movement and like heard about this transition from pets to cattle, where originally you're like naming things and like taking care of them, towards like the cattle model where everything just has a number and it's like really replaceable. And so Cilium is doing that for networking, observability, and security. It's giving things an identity. And so suddenly with these identities, you're able to do a lot of interesting things. So rather than saying this IP can talk to that IP, you can suddenly say front end talks to back end, and it doesn't matter like where those containers are running or like how long they've been around. You can do things based on an abstraction of this identity. And that provides a lot of like powerful new ways to do things because you can suddenly label things, you can sort things by like the metadata like around them, and then you can do things around like connecting things, observing how those connections work, and also like seeing what should and shouldn't be talking to each other.
I mean, that's right up Kubernetes alley of namespaces, if I'm completely mistaken, and location independence when it comes down to cluster technology.
Yeah, exactly. And that's what Cilium is trying to provide, where it's providing this like higher level abstraction of what you're trying to implement. So like a lot of times it's like the business logic, like these kind of like namespaces should or shouldn't be able to talk to other ones. Like one of the examples I like to give is actually like Bloomberg, for example, is using Cilium to do like network policy, right? And so they have a lot of financial data. They don't want that data kind of disappearing out of their system or like, you know, going across multiple different customers. And so they're able to lock down who can talk to who with Cilium.
You just mentioned very interesting names, namely Bloomberg. If I take a look at the Wikipedia page of something called eBPF, I see pretty much I'm almost tempted to say the top 100 kind of business and technology companies who are using this technology. The likes of Netflix, Dropbox, Google, Cloudflare, DoorDash, Shopify, Trip.com, DigitalOcean, by the way, Apple, LinkedIn, Yahoo Inc. Samsung apparently uses that for their smartphones. So does the Android project and all the rest of them. I think it's hard to spot any major player that is not on this list.
Yeah, I think that's really like the cool thing about eBPF is it's actually being used in so many different places already. And it's kind of like this underlying technology that's unlocking a lot of potential and allowing you to do a lot of interesting things. But the great thing is you don't even have to like know about it. In fact, I think the craziest one for me is like if you have an Android phone, you're using eBPF today. So you can think that's literally billions of devices around the world are already using eBPF today. And what they're using eBPF for is to essentially monitoring different networking statistics. So being able to tell you like how much data you've used. So if you have an Android phone in your hand right now, if you're listening to on one, then you're actually using eBPF right now.
Very interesting. Given the fact that this is used left, right, and center, where do you see this going in the kind of near future, long-term future, that sort of thing? Because for me, the networking angle alone opens up a whole slew of technology way beyond the use cases you just mentioned.
Yeah, absolutely. So I think there's like a couple different ways to take this question. So I was talking to Daniel Borkman, he's the co-creator of eBPF, about like kind of what is his goal with it. And right now we're just past the 10th year anniversary of eBPF being merged into the Linux kernel. And he said it'd be amazing if it's a 20 or 30 year technology, just like the Linux kernel itself. And I really see like it has that potential because of what it allows us to do in the Linux kernel. I think Linux was kind of in some ways became boring for a little while because it took so long to change things. If you wanted to upstream something into the Linux kernel, you could do it. It might take a year of convincing the rest of the community it was worth it. And then maybe 5 years later, you get it into the LTS release provided by whatever distribution that you choose, right? And so suddenly with eBPF, it turns all that innovation cycle on its head. You can write an eBPF program, load it into your machine without rebooting anything, and then have the new functionality that you want on the fly, right? And so one of my favorite stories about this is Brendan Gregg is talking about how he's in meetings at Intel, and he's saying customers are asking them questions like, how is this specific thing working? And he could program eBPF programs and answer their questions by the end of the meeting, right? So this isn't a new functionality that's coming 5 years from now. It's coming by the end of the meeting, and we're answering the questions that we want to right now. I think we're really seeing that start to take off. It took so long to kind of get into the mainstream because of this innovation cycle of the Linux kernel, right? We need to be merged into the Linux kernel. We need to add more functionality to it. And then that functionality needed to actually land in the distributions that many people are using. So, right, 5-year-old Linux kernel versions. And now those are just kind of hitting production, and we can start to do interesting things. So things like rewriting or reusing the networking stack, doing things like tracing, or rewriting the CPU scheduler, right? And I think this is really exciting for me because what it allows us to do is to experiment around how we do things for the Linux kernel, and then bring that kind of ideas, that innovation, that knowledge back into the Linux kernel itself. So it's kind of unlocking innovation and then allowing us to bring it back into it. And then kind of taking that a little bit further into the Cilium project is we get to rewrite a lot of the different parts of the Linux kernel networking stack. And it's also the same question, what do we want to rewrite first? And so the first thing that we focused on was kind of doing the layer 3 networking for containers, because that was the initial kind of gap that Thomas and Dan, the other co-founder of Isovalent, kind of saw in the market. And then now Cilium has expanded from layer 2 all the way up to layer 7 and rewriting so many different parts of how we do things. And actually one of the projects that Daniel's working on right now is actually working on essentially making container networking just as fast as host networking with eBPF, right? So there's so many different things that you can do. And then when we're able to do that, it unlocks a lot of innovation about what we can do. I think that's really the exciting thing about both eBPF as a whole technology. It applies to so many different areas of the Linux kernel, which is kind of this fundamental technology that we almost all of our compute relies on. And then also for Cilium itself too is we can rewrite so many different things to make it safer, faster, more secure, more performant, more scalable. And I think that's really exciting too.
It sounds very promising. Well, when you talk about rewriting kernel schedulers and things like that, so I'm assuming you could think that there would be, compared to a native kernel program, some performance issues with running an eBPF module. Is that true? Is that not true? How does it compare to writing a let's say bespoke kernel scheduler itself, right, in the kernel itself? Yeah,
so there's kind of a couple different parts here. So eBPF programs themselves, the performance, like any good answer, it depends.
Fair enough.
The thing is in some ways they're very efficient, right? So it's compiled into a machine-specific instruction set it's basically as fast as natively compiled kernel code. But the thing about eBPF programs is that they run on events, right? So they're not just kind of running in the background; they're running on specific events. So it depends on how much that event is happening, right? So if you're trying to, monitor all of the database reads on a database that's high transactions, right? That's going to put a lot more of a performance hit on your system. Well, as if you're trying to see when is the time that people are opening a specific socket like over here, and it would only be a malicious actor to do that, then it's not going to be very high either. There's some interesting kind of like numbers around this too, and it depends on like how you're doing it. But the overhead for eBPF in general is quite low, as long as you design what you're actually trying to do or look for smartly, right? And so you can see everything and hook into everything that's happening in the Linux kernel, but you don't want to, right? If you can narrow that down to the specific use case or like the business like kind of goal you're trying to achieve, it's very performant and very efficient. I think that's why people get excited about it too, is like you can do a lot of things that you couldn't do before. I think the classic use case is for this is actually around security, where a lot of the time security teams had to make kind of this security performance trade-off, where it's like, yes, you can monitor a lot of things. You can either like monitor a lot of things for security and take a performance hit, or you can monitor less things and not take as much of a performance hit. But now with eBPF, there's not that much of as much of a paradox, because you can monitor everything, but you only take a performance hit when it actually happens. And that's actually important. So if you know what you're looking for, like that's great, because then you can have really specific eBPF programs and only monitor those. And they're only actually running when the bad
events. Okay. No, that's promising. How does this integrate with any other technology? Is it really standalone, or are there other frameworks it works with?
Yeah, so a lot of what I've been talking about so far has been like Linux kernel this, Linux kernel that.
Yep.
I think that's a little bit of an overstatement. I think I say that a lot because it's where it originally began from. And it's where kind of like some of the biggest use cases are right now. But it's actually, it's kind of funny, eBPF, we have been talking about it so far is actually kind of like the eBPF runtime for the Linux kernel, whereas actually eBPF is actually just kind of like an instruction set. And there's work right now to standardize the eBPF instruction set in the IETF, right? And then you can implement different types of runtimes too. And so there's actually a couple of examples of that right now. So for instance, there's an eBPF for Windows project going on that will allow you to run eBPF programs on Windows, right? So you can extend functionality across either operating system. There's also eBPF runtimes that run in user space. So it doesn't have to be in the Linux kernel itself. You could also run the eBPF programs in user space itself. And so like one example is around, I think it's the Solana blockchain uses eBPF in their like VM to do some stuff too. You can also implement eBPF on different types of hardware too, right? So there's a lot of different use cases, and that's kind of, it's just the general instruction set. I just usually talk about like kind of like the Linux kernel runtime because it's kind of like the one that I work with the most.
That's a very interesting perspective, because if you want to move this thing into user space, I'm almost tempted to say you're facing competition from the likes of ranging from legacy technology like the JVMs of the world, as in Java Virtual Machines, right up to what the hipsters call WASM, as in WebAssembly, because that field is heavily populated already in userland.
Yeah, I don't disagree. I'm not heavily involved in a lot of the user space eBPF runtimes. I just kind of know of them.
No, very interesting. Changing tack just a little bit. How did Bill end up with the project, and where do you originally come from?
I come from a small farm town in Wisconsin. We had drive your tractor to school day, and
I see.
we had more chickens than people in the town. After that, I got my undergrad in biochemistry, and then went and got a social science of the internet. So we like to say we were masters of the internet before I somehow ended up in tech. So it's been a very, I guess, kind of roundabout route, but that's how I ended up here. And it's really funny for me, like before Isovalent, I was at the Cloud Native Computing Foundation, kind of like the center of this whole like cloud native industry. And then I remember, and I'd kind of been in the industry a while, and then I remember showing up on my first day at Isovalent, and there's all these Linux kernel engineers running around, and I'm like, wow, I have not done anything in my career. I have absolutely no idea what's going on right now. And so that was a really fun learning curve again, is kind of diving into the internals of Linux kernel. And that's been a really fun journey at Isovalent.
Of course, that begs the question, which we normally ask many of our guests. How did you end up on the dark side, apart from the fact that dark side actually has cookies? As in, how did you get into tech in the first place, given this background? As in heavy, down-to-earth Linux stuff.
Yeah. I wrote my master's thesis on how scientists use AI for cancer research. Then my best friend, my master's program convinced me to move to Berlin. He's like, it'll be great. I packed a backpack, booked a one-way flight, and slept under his bed until I found a job. That 4-person startup was doing a machine learning platform on Kubernetes. Had no idea what Kubernetes was. Thought it was like this amazing Greek island. It ended up with me on my Windows laptop, having never seen the command line, setting up a Kubernetes cluster using like PuTTY and like Windows virtual machines. And it took me like 8 hours to set up a Kubernetes clusters. And that was like my, I would say, headfirst introduction into tech.
8 hours for a single node Kubernetes cluster on a Windows machine.
Yeah.
That's pretty close to magic, I suppose. Given your background.
Yeah.
No, jokes aside, I mean that's a natural, no?
Yeah.
So why did you waste that time with other education prior? I wonder. No, I'm joking, but you
Yeah.
So I mean, it never occurred to you to go into tech right away in terms of study technology or rather computer science from day one, rather than taking all these diversions.
No, my mom was actually a breast cancer researcher. And so I'd actually been working in research lab with real mice rather than computer mice since I was a teenager. So for a while, I thought I was either going to be like a doctor working on like basic medical research, or like a real doctor helping out people. But then I took a left turn when I went and got my master's.
So you were just a bit dented already. Okay, got it.
Yeah.
But exactly. I think Martin has a question too.
Yeah, I was going to ask. You didn't enjoy the tractor driving then?
Sorry, what was your question?
You didn't enjoy the tractor to school driving?
No, I think I'd had a bit enough of that. I wanted to see the wider world, and tractors just don't drive fast enough.
That's very true. Takes a while. On a slightly different note, there is an eBPF Foundation, right? And how does that work together with the Linux Foundation? What is its main kind of role in the whole open source ecosystem?
Yeah, so the eBPF Foundation is kind of like a sub-foundation under the Linux Foundation. So it is kind of like managed by the Linux Foundation. But the way the foundation actually works is it's a bunch of member companies kind of like pay membership dues to support everything in the eBPF ecosystem. And so it does a lot of great work, kind of like both promoting the technology and improving the upstream technology. And so like some of the different things that they do, so like on the marketing side, they help support like the eBPF documentary to tell the story, which is I think close to like 100,000 views on YouTube now. They wrote a State of the eBPF report to kind of hand to CTOs, CISOs, CIOs to help them understand like how eBPF is being used in production and kind of like what it is as a technology. We work on like different research report. We help sponsor conferences in the ecosystem to bring together developers to discuss important topics. We sponsor like right now we're sponsoring academic research. So we have grant funding out to help support academics who are kind of like pushing forward the state of the art for eBPF. And then we'll also support like upstream development. So everything from kind of like doing kind of like different statements of works with contractors to get development that no one company wants to kind of focus on, but the ecosystem as a whole would benefit from. So kind of like improvements around that. And then also doing things like a security audit of the eBPF verifier, right? Because that's really critical for the safety of eBPF as a whole, and also doing a threat model so that people can understand. So the eBPF Foundation does a lot around kind of like promoting and supporting kind of the upstream eBPF project.
But isovalent was your second job in Germany? Did I understand that correctly?
It's actually my fourth job in Germany.
Fourth job, okay. Wow. So how did you end up at isovalent?
Yeah, so I was at the 4-person startup, and like any good startup, that one died and went out of business. And so I moved on to my second startup, and that was a kind of like a cloud native, a bootstrap cloud native company out of Hamburg. So have a lot of great memories of going there and eating Franzbrötchen and talking about like the state of multi-cluster Kubernetes. We were doing a lot of stuff around that. And then I wanted to do kind of like more stuff to help out the community, like helping out the open source ecosystem. And so that's why I headed over to the CNCF. And that was a really great experience, kind of like looking on like a global stage. How can we help build and grow communities focused on kind of like all these cloud native technologies? While I was there, I actually kicked off the Kubernetes Community Days program, which now I think they're heading towards like 50 events around the world this year, all organized like locally, individually on the community level, which I think is really cool. And then I saw that Cilium was a really hot and growing technology in the ecosystem, and I thought it was the right time to jump on board that train. And the way I actually ended up here is quite a funny story. So my boss is Liz Rice, and we had biked together at like a couple different KubeCons. I had like organized some bike rides, and I saw on Twitter one day that she posted like, "Hey, I'm going to hire somebody for my team. Let me know what you want to do." And so I just messaged her and I said, "Here's the job description I'd like to do at Isovalent." And I'd taken the job description from what I'd wanted to do at the second startup that I'd worked at, but they didn't have kind of like the room for me to do it there. And I told Liz, and I was like, "Hey, this is what I want to do. I want to help grow the Cilium and the eBPF communities." And yeah, the rest is history. They hired me.
Pretty impressive. Now, if you came to Berlin, but you still live in Berlin, is that a correct assumption?
Yeah, that's correct.
So how do you find Berlin different from, say, rural Wisconsin? Because I reckon, given the fact that Berlin, and we're talking about Berlin, Germany now, is Germany's capital.
Completely the same.
Exactly. I mean, if you venture into Brandenburg, which is the surrounding federal state in Germany, you would be looking at the German equivalent of Wisconsin, I suppose, to some extent. But I reckon that Berlin is quite different. So what has been your? I mean, you have been living there for what, 10, 15 years?
I've been there for 6 years.
6 years, okay. So still a newbie, so to speak. So what's the experience then, with regards to kind of compared to rural Wisconsin? Apart from the tractors.
I think Berlin's a great city. It's really served me well because it allows you to kind of be whoever you want to be. And I think I've been able to take that a lot of places with the different startups that I've been. I've got to grow through a lot of different roles and do different things. And I think Berlin, it also has a really great tech scene too. I've met a lot of people who have kind of like changed my career here too. I think that's maybe something that people don't talk about as much, is like, for instance, like Prometheus was founded by a team here in Berlin, and a bunch of the engineers are here too. So there's actually like a lot of, like people to know in Berlin too. I think though my favorite story about Berlin is at the first startup I was at. I was part of this program called the German Accelerator, where they sent kind of all these like young German startups to Silicon Valley to kind of like learn about the US tech ecosystem. And while we were there, we got to meet like some like, kind of German government officials, because they wanted to see like the payback of their program. And while we were there, I was like chatting with one of them, and he's like, "Oh, how do you like Germany? How do you like living there?" And I was like, yeah, I really love Berlin. It's like such a great city, so international, so many different things to do. And he's like, let me know when you actually see Germany.
Okay. Interesting. So, Martin, please take note.
Have you seen any other bits in Germany yet?
Yeah, I'm actually a really big biker, so I've biked all around the country now. So I've seen lots of very small towns that many people have never seen before.
Now, Martin, please take note. I mean, given the fact that you're running marketing because you're firing, this is the way to do it, right? So you take an immigrant with a high level of kind of technology skill sets, you put them onto a leading open source podcast, and then prior to doing so, you give them a free pad in Berlin as in kind of luxury accommodation. So he does all that city marketing for you. So, see, Martin, this is how you do proper marketing for a change.
The free pad is going to be kind of expensive in Berlin.
Yeah, I don't know.
I'm just guessing.
that could have worked when Berlin was poor but sexy, but now it is expensive but sexy.
I guess you still got some of the eastern side flats in
so concrete. If I may be so nosy, where do you live in Berlin? Mitte or kind of on the outskirts like Charlottenburg or?
I actually live in Mitte, but I'm 2 blocks into Berlin. So
again, is 2 blocks away from?
I live 2 blocks into East Berlin, so I actually live in a Plattenbau.
You do? Okay. Are they still around? I thought they were all kind of been demolished about 20 years ago or something. Okay.
Yeah. So
interesting. So that luxury path thing didn't work out. Berlin marketing, if you're listening, there's room for improvement on your side. No, jokes aside, is there anything we should talk about before we wrap this up? Now would be the time. Berlin, eBPF or not?
I think we've covered a lot of different things. I think it's hard for me to think of a lot of other things. I think you've had a great set of questions, and it's been a fun conversation. I think the only thing that I'd probably want to leave people with is kind of 2 analogies that I really like to kind of talk about when I'm discussing eBPF. And so the first one is if you kind of remember the whole marketing thing around Intel inside, right? Everybody kind of remembers the logo and the kind of jingle that went along with it. And it was a really powerful marketing technique because if you think about a lot of normal people who didn't know technology at all, they're like, I don't know what Intel inside is, but I kind of want that, right? And I think we're kind of getting to the same point right now with eBPF is I don't know exactly what eBPF is, but I really want eBPF inside the projects or the products that I'm using. But I think kind of the difference is there's really some bite behind it. As we were talking about kind of on this podcast, eBPF allows you to do things in ways that weren't possible before, right? So it provides more flexibility, it provides more performance, it provides more scalability, and kind of this eBPF magic dust sprinkled on top. I think it seems like magic, but if you actually look inside, there's actually some power behind it. And so I think we're really starting to see this now, and you see in the adopters already, people are choosing the products and the power and the projects and the products powered by eBPF with eBPF inside because it allows them to do things that they weren't able to do before, like faster networking, better observability, more secure systems, right? And or it provides them more flexibility, things that they literally weren't able to do before. And so the last analogy I'll leave you with is I really think of eBPF as kind of an app store, right? So the iPhone changed how we interact with technology. I wouldn't say especially because there's something you can hold in your hand or a touch screen. I think the thing that it really changed is before you had these phones that came, it was the hardware and the software all bundled together. And right, you had whatever functionality they gave you, right? But now with eBPF, with the iPhone and with the App Store, you're able to download new functionality on the fly to get your phone to do exactly what you need to it, whether that's get directions, order food, listen to music, right? There's all these new functionality that you can download onto your specific machine to accomplish whatever you're trying to do, right? And I think that's the really powerful
for the Linux kernel. Yeah, okay.
About eBPF is it allows you to add functionality exactly when you need it to accomplish, instead of the personal goals, the business goals that you're trying to do with your technology. And that's why people are going to start choosing eBPF powered technologies more and more.
Nice. Where do you see this in the let's say the maturity adoption phase? Then are we still fairly early, or is it mainstream? Where would you class this in? Normally you have like hype cycles for certain technologies, right? Where do you see eBPF in the maturity stage?
Yeah, I think that's an interesting question. I think there's...
Or let's say adoption stage, right? Because that's more important. Yeah.
Yeah, I think that's kind of like how you look at like technology being adopted, because kind of like eBPF is this under the hood technology. So every time you're accessing any Facebook service, WhatsApp, Instagram, Facebook, right, you're actually using eBPF. Yeah. Every single packet going out in and out of a Facebook data center is processed by eBPF. 90%
in general, packets, exactly, yes.
90% of the packets going in and out of a Google data center processed by eBPF, right? Every time you pick up your Android phone, eBPF, right? So in terms of like where it's actually being deployed today, like I would say almost everybody's using it already. But in terms of like kind of like the mainstream technology adoption, like Cilium's become the standard CNI in Kubernetes, right? But not all workloads are in Kubernetes. And so I think I would say the vast majority of people are already using eBPF, but if you look at the whole technology landscape, there's so many different things that we do. And so eBPF still has a lot of room for growth in terms of like tackling all those different things too.
Okay, final question from my side. Given the fact that actually eBPF made it into almost outer space, never mind the fact that the Mars rover is actually running Linux, where do you see the eBPF's future in outer space?
eBPF future in outer space.
Vogons or not? I'm joking.
Yeah. No, actually, I think like one of the cool use cases I didn't talk about eBPF is it allows us to like add new functionality. So one was like there's a bunch of like drivers for different things interacting with the Linux kernel system, and not all of those drivers work, so they have little bugs, and you can actually fix a bunch of those on the fly with eBPF. So I can see eBPF being embedded into different types of hardware to run different types of systems that are being sent into deep space.
So Elon Musk, if you're listening, eBPF is the thing you want to put into SpaceX on the very top of the priority list, just in case your venture will eventually check out. And with that, I think it's almost time for the boxes, Martin, or rather Bill. So what's your pick of the week?
My pick of the week.
Anything you've come across worth mentioning in the last 52 weeks? Make that 2? I don't know. Your take.
I mean, I'm in Berlin right now. It's the European Meisterschaft for
soccer. Yes.
I'm not a big soccer fan, but it's so prevalent. They built a goal bigger than Brandenburg Tor. So
okay.
It's not my personal favorite, but I feel like living in Berlin, it's so prevalent in my life right now. I would be remiss not to say that.
See, Martin, this is how you do it. At the very far end, you put another statement, and the pad is just around the corner in terms of you get a call from the city marketing tomorrow morning. Fair enough.
Yeah.
Thank you. No, I'm joking, of course. This show wasn't sponsored by Berlin City Marketing, full disclosure. But Martin, what's your POX then?
Yeah, well, we don't have any European Meisterschaften over here.
But Europe for starters.
But we do we do watch it occasionally, yeah. And England are still in it as well. So yeah.
Why? It begs the question. I mean, given the fact that Britain has defected 6 years ago or something.
No, but that's an economic union, isn't it? It's not a sports union.
I see.
Yeah. Anyway, what would you do without the English hooligans?
Surviving, I suppose.
Or the German pubs. Yeah.
Okay, over to you, Martin. Apart from soccer, anyway.
Yeah. No, I go with the soccer idea. I really like that.
You do? Okay. Well, in the case, my pick of the week is not soccer related. As a matter of fact, it's a book and also a TV series called The 3-Body Problem. don't know if
The
that
three
rings a
what
bell.
problem? Three bunny. Or...
No, the three. No, Martin, it's not three bunnies. It's the three body problem.
Oh, okay.
It's
It
links
must
will
be
be
quite
shown
problematic
notes.
having three bodies.
Well, no, actually, and you know who alerted me to this book originally? Anyway,
Do tell.
a little lady, or rather a smart lady called Countess Vladessa.
Ah, I see. Okay.
Yes, I won't give away too much. It's essentially a book about where we come from, where we go to, and what happens in between. It's rather worth watching or reading if you're so inclined. Essentially, it's far from your ordinary run-of-the-mill sci-fi novel. No, it's far from it, actually, because it does provide a lot of food for thought. And with that, I'm going to leave it at that. Bill, that has been more than interesting to talk about this.
Yeah, it's been great.
And thank you for being here.
I have one more pick of the week.
Yes. Oh, just go ahead.
Yeah.
As long as it's not soccer related.
Yeah,
I'm joking.
I feel like I
Berlin
could leave it on that note, But my pick of the week is the Tour de France Unchained, the documentary from Netflix about the Tour de France.
Okay.
I'm a massive cycling fan, but I think all of my friends that I've talked to about it really love it because I think it makes cycling very approachable and really shows kind of like the drama inside the heart of the peloton. And I think the biggest thing that all of my friends that kind of like watched it that aren't into cycling is like, I never realized that cycling was a team sport and that all the teammates are relying on each other so much. I think like that really resonates with like what I do because like I really see open source also as a team sport. And so that's why I like cycling is because you're all working together towards a common goal. Even if there is only one winner, you're all working together to support each other. And I think that's the fun part about open source too, is you get to work with so many great people. We get to have conversations like this. And I think that's...
Did you cycle competitively or is it just for fun?
I used to race competitively, yeah.
Interesting.
Nice.
The final question, of course, is how do you cycle without chains if it's unchained?
Very carefully or only downhill.
I had to squeeze that in, sorry. Netflix, if you're listening, sorry. I do apologize. Okay, and with that, people, thank you for listening. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.